Welcome to this brief introduction of JeVois Pro. Let's start with an overview. JeVois Pro has a lot of different connectors and features. Here is how to correctly insert the micro SD card. Use this orientation. The golden contact should be facing towards the front of the camera. And make sure that the card is fully inserted, otherwise the camera will not start. Here is a video. Put the card in, listen for the clicks as you push it in. Click, click, it's in. Push again, click, click, it's out. Make sure you always push to eject the card before you try to pull it out. Click, click, it's in. Push again, click, click, it's out. If you don't have any fingernails, you can use tweezers. Let's see how that works. Put the card in, push it in. Click, click, it's in. Push again, click, click, it's out. And then take it out. To start using your JeVois Pro, connect it to an HDMI TV or monitor, keyboard, mouse, and of course power it up using the power adapter that was included. Be careful when you are going to use this camera on a mobile platform to make sure to provide strain relief. Here, for example, we have those 3 red zip ties to make sure that no stress will occur on the micro HDMI connector, otherwise the connector could break. Let's see how the camera boots up. It starts with a little logo, then a standard Linux booting process. We're actually running a full Ubuntu on this camera, and then the machine vision software starts automatically. The main thing that you are going to want to look at is how to select different machine vision modules. There are 3 different categories. The Pro modules are designed specifically for JeVois Pro. Legacy also work on the older JeVois model, and no USB or headless modules are ones that will not have any display. Here we are looking through the list of available modules, so each one of those corresponds to a different machine vision algorithm that can run. Here is the multi-DNN that we showed in the Kickstarter demo. This one is running 4 deep neural networks in parallel. Here those networks detect a bunch of books in my office. Each module has some little documentation under the Info tab of the graphical interface. This is just documentation to help you get started with this module, to explain roughly what it does and how to use it, so you can read that. Then if you switch to the parameter tabs, you will have access to a number of settings that are available for each module. When you hover over the name of the parameters, you see their full name. If you hover over those little question marks, you will get some information about what each parameter does. If you need to go back to the original value, you can press those little reset buttons. Now, in addition to parameters that are for a particular machine vision module, there are also parameters that are global or system parameters. Some parameters here, for example, just decide where is the camera sensor, what kind of sensor it is, and so on. Those cannot be changed at runtime. As you can see here, they are grayed out. So if you want, you can hide the ones that are frozen and instead just focus on the ones that you can actually change at runtime. Here, for example, we can change the maximum frequency of the CPU. We can set it to just 500 MHz. You can see that behind, it's not very visible here, but now the frequency of the CPU has been changed to indeed 500 or 499 MHz. It's more visible now. Then if I put it back to the default, which is 2.2 GHz, then you can see that now it gets updated. So you can change those parameters at runtime. Some that are of particular interest when you get started are parameters for the graphical user interface. We have several here. You can, for example, allow to quit on escape key. By default this is disabled, but if you want you can enable it. You can also choose how quickly the interface will disappear when the mouse or the keyboard are not touched. For this video I'm going to just set that at 5 seconds so that the interface will disappear rather quickly. Finally, you can change the scale. If you like smaller text, you can make it smaller, quite a bit smaller. So make sure you have a big screen TV or good eyes. Here I'm going to put it back to normal, but you can see you can choose whatever scale you want. And you can also change the color theme if you like. So if you prefer a dark color set, or this is the classic from the ImGUI interface. JeVois Pro has a console that allows you to see both machine vision module outputs and also system messages. Here we can see a mix of those two. You can direct either the log messages, which are those system messages, or the module output messages to various interfaces like a serial interface, USB, or the graphical GUI. You can also enter commands in that console. If you type help, you will see a list of available commands and parameters. There are some errors here, but we are going to remove them very soon. Those are just camera parameters that couldn't be accessed. And you can type either commands that are specific to JeVois Pro, like for example this info command. There is a list of all the available commands on the web. Or there is one in particular that's called shell that allows you to just pass down commands to the Unix shell. So for example, here we look at the amount of space used in the disks. If you switch to the next tab, camera, that will allow you to access settings of the camera sensor. For example, here we can play with the contrast setting. If you modify it and you don't remember what it was, you can just press the reset button to get it back to default. Here we can switch to manual white balance. Once you are in this mode, you can then set the white balance temperature to match the kind of lighting that you have. In this case it's fluorescent, so probably closer to 2000 Kelvin. Different values are reflected immediately in the camera. The next tab is for configuration files. Those allow you to set how JeVois starts and also configure what kind of modules are available. Or one that is of interest here is the list of deep neural network models that are available to run. You can see here for each model we have some entry and with some parameters that tell the camera where to find the weight file, where to find the list of classes, and these kind of things. You can edit those files. Here I'm just going to put some dummy comments, and then you can save them to disk. And usually when you do that, you will have to reload the current module, sometimes restart the camera. If you switch to the next tab, which is code, you can view the source code. All of the machine vision modules included in JeVois are open source, so you can browse their source code. When it's in C++ currently, this is only to view. We may at some point allow you to compile C++ modules on the camera. However, when a module is written in Python, you can already edit the code and immediately see the effects. Let's take here this little Python sandbox. This one is just drawing a rectangle and a circle on the screen. We are going to look at the source code for it, and then let's modify it a little bit. So we browse through the code. We find the function that is actually doing the drawing. It's called process GUI. You can see here we have two lines. One is drawing a circle, the other one is drawing a rectangle. Let's change the radius of that circle. We save, and you can see immediately you get the effect. The next tab is for system information, parameters. This one is still kind of under construction. You can see here how fast the fan is spinning, what kind of neural accelerators are installed on this particular camera. You can, we will see later how to create machine vision modules. You can ping the server that we will later use to download models. This camera is not connected to the internet, so it doesn't ping. And finally, you can change what you want to boot into, either the JeVois software like we did, but you can also boot into the Ubuntu console or graphical interface. The last tab is for tweaks. This one, first of all, shows you a little OpenGL demo, which was part of IMGUI. You get access to some display parameters for the video. You can see that this is all OpenGL display, so you can really play with it. And you have access to a number of additional settings that are related to the graphical interface, the dear IMGUI. So in this one, you can change all kinds of parameters. We will later allow you to save those so that you can customize the interface exactly in the way you want. You can see here, for example, the window rounding that changes how round the corners of the windows are. If you look at that little corner, when we change a parameter, the roundness changes. Another thing which is interesting is you can get some statistics about how fast the graphical interface is running, how many polygons we are displaying, and so on. This is also part of the dear IMGUI graphical interface that we are using. And finally, you get a demo for that graphical interface which shows you all the possible kinds of widgets that you can create. This is something that you will be able to use when you create your own machine vision modules. So all of those widgets are available, different kinds of sliders, entry, color pickers, you name it. So again, all of those are available from the C++ side. So when you program a module in C++, you can instantiate any of those widgets, and here this little demo window allows you to basically figure out which widget you may want to use, and then you can go back to the source code of that demo and see how to actually implement a similar widget for your own machine vision module. Okay, let's play now with the built-in vision modules that are bundled with your camera. We are going to go over them in order. Let me make this window a little smaller here so that it gets out of the way. And let's start with the first one, which is a deep neural network module. By default, it runs a classification network. That network believes my office here is a bookshop or a library, which is pretty reasonable given the number of books here. This module has a number of parameters. The one that you want to look at are under pipeline. So here you can see you have preprocessor, postprocessor, these kind of parameters. The most important one is the one that's called pipe under the pipeline module. This is where you select which neural network is going to work. You actually select a pipeline of what kind of preprocessing you want, what kind of network is going to run, and what kind of post-processing is going to run to display the results. So here let's select, for example, something that is going to run on the TPU. This one is detecting a bunch of books, as it should, on this bookshelf. And again, that's running now on the Google Coral TPU. That bottle, it doesn't like it so much, maybe a little bit. Let's see another one. For example, something running on the NPU, which is the neural accelerator that's integrated into the main processor of JeVois Pro. This one is also detecting a bunch of books here. Let's do a semantic segmentation module maybe. For example, this one is supposed to be a pet detector, and here it is. It's official, I am a pet. Maybe not hairy enough, but pretty close. The AR Toolkit module has some problems, so let's do the Aruco module. So this module detects little markers. If you want to find some of those, you can download this JeVois guided tour and browse through the pages. It was originally written for the older JeVois camera, but we are soon going to update it for JeVois Pro. So you can see on this page, for example, we find a bunch of Aruco markers and we check that they are detected. This module is interesting. It can create some 3D, like augmented reality outputs. So if we turn on those two parameters. This is now going to show a 3D axis and also a cube on top of every Haruko marker that is detected. Pretty nice module overall. Next one, we are going to look at a simple background subtraction module. So this one learns a model of the scene over time, and it basically adapts to things that are not moving, so that later on when a foreground moving object appears, this module is going to basically detect those foreground moving objects, and it can alert you that something arrived. You should use it with fixed gain and white balance instead of the automatic gain and white balance. Here is a module that shows the IMU, or inertial measurement unit, that's in JeVois Pro. This is a 9 degree of freedom, 3-axis acceleration, 3-axis gyroscope, and 3-axis magnetometer. It's mounted right behind the camera sensor chip, so it's rigidly coupled with the camera sensor. And you can see here the instantaneous measurements of that IMU. Let's move on to the next one. Here is a little QR code detection module. So again, from that JeVois guided tour, we have some QR codes. I'm looking for the page here. Here is one. And you can see this one just contains a little string that says office. If I move the book a little bit lower, we are going to see it at the top of the screen here. You can see that the coding of the QR code indeed says that it found office as an embedded string inside that particular QR code. Let's move on to the next one. This is a simple edge detector. It's mostly for tutorial purposes. This is a very simple module to write. You can look at the source code and try to understand how it works. You can play with the parameters. Those are basically the parameters of a simple canny edge detector. When you play with the parameters, it changes the density of edges and the fineness of edges that are being detected. You can see here, look at the source code. It's very short, and there is really not much to it. So again, this is mostly a tutorial kind of module. Next one is a module that detects QR code, AR toolkit, and Haruko markers all at the same time. Again, here I don't know what's going on with the AR toolkit. I think maybe I'm on the wrong dictionary, so they don't get detected. We'll fix that very soon. Here is the multi-DNN. This is the one that we have looked at already, with 4 different neural networks running on possibly same or different accelerators. Each accelerator, for example the TPU, can run several neural networks. If you only have one TPU and you run several neural networks on it, then of course they are going to be time multiplexed, so they are going to run slower than if you are running only one neural network on a particular accelerator. Here again, the pipe parameter decides which neural network runs, except in this case we have 4 of them. We have one for each of the quadrants of the screen. Here one of them was a face detector in the top left, and indeed it seems that it's working. There is another version of this one. Oh yeah, so here is when we change the different pipe parameters. So there is a P0 pipe that's for the top left corner, P1 pipe is for the second quadrant, and so on. So you have 4 pipe parameters in that module, and you can select whichever neural network you want for each one of those. Yes, so there is another version of this which is called multi-DNN2, where now we run several neural networks, but we display the results of all of them on a single display. So here we are running 3 different neural networks, and we display all of the results on the same display. So we start getting a lot of boxes here from those 3 networks that are running in parallel on the same camera frame. You can see here each one of them has its own little window that shows the different parameters, the image resolution, and so on, and the time it takes for the different stages of the network to run. This one is a simple test module. It's called pass-through. It has a number of debugging features that you can try out. For example, here we are capturing both a color frame and a grayscale lower resolution frame from the camera sensor. We capture both at the same time. You can play with that grayscale frame. There is also a little test mode which shows sometimes some aliasing artifacts. You can eliminate those in some cases. This is something that we will discuss later. The next module is a Python module that is doing classification using the Google Coral TPU accelerator. This is mostly to show you how you can write your own Python code that will access the Coral TPU, and in this case with a post-processing which is of classification type, so just showing a list of classes. There is one also which is for detection. So in this case, the neural network is generating bounding boxes for the different things that it sees. And finally, there is one also that is for semantic segmentation. So in this case, this is again the PET detector network, and the network generates an overlay that goes on top of the original image. Here is a media pipe module. So this one is using the Google media pipe to do detection of facial landmarks. Currently this runs on the CPU, but as you can see, it runs at a fairly decent frame rate. Next one, we have a couple more media pipe demos. One is a hand detector. This is again written in Python, so it makes it very easy. If you want to modify the code, you can do it directly on the camera. There is no recompilation that is needed, and you can just implement your own version of this. Here is that sandbox module that we have already looked at previously. Again, you can use this one to start playing with writing Python code, looking at the results in real time on your camera. Let's switch now to legacy modules. So here there is a whole other list of modules. Those were initially developed for our older JeVois model. In this case, there is no graphical user interface. So what those modules do is that instead they create a picture with drawings that are directly in the picture. So you can see here the detections of those arrow markers are drawn directly in the picture. This one was also trying to detect some blue object, but maybe a different blue than the one that I just showed. Here is another one, for example, that's running some deep neural network. This network is running on the CPU. It's not particularly fast, but it works quite well. The accuracy is pretty good. You can see here in the top left the categories that are detected, again, bookcase, bookshelf, these kind of things, library. Yeah, much slower than when you run it on a TPU or NPU. Here is one that shows you the speed difference when you do a simple blur operation on the CPU versus using the special multimedia instructions called Neon for the ARM processor. So this shows you that you can get a lot faster image processing if you use those special Neon instructions compared to using regular CPU instructions. This is a very fast motion detector. It can run at several hundred frames per second. The top half is showing horizontal motion, and the vertical half is showing vertical motion. I'm just moving my hand here in front of the camera. Very low resolution here, but again a very fast frame rate. Finally, let's look at some headless modes. So in headless mode, this is what we should all strive to achieve at the end. There is no more display. which means that the camera is computing something, but it doesn't need to show it to any human. Instead, when you are running in headless mode, you should go back to the console and look at the kind of messages that are generated by the camera. In this case, we are running the arrow code detector, and we can see by choosing different levels of detail here so in this case, we are detecting two different arrow codes, U45 and U30, and we can show either just the location, or now we are showing a rotated rectangle that's fitting the arrow code, or here a full polygon around each arrow code marker. And that's it for today. Enjoy!